Well, thank you everyone for coming. As you know, this is the seminars we do at the Institute every other week. So today we have the privilege of having Dr. Mazzoni here. She works, she has been working since June 2018 at the Institute as a project scientist. She's working on several projects that are very, very exciting. All of them related to risk, resilience, earthquakes, ground motions, and other topics that I think are very relevant for us. And personally, I would like the Institute to be more involved as well. So it's very excited, and hopefully we can all learn a lot from it. Okay. Short introduction.
Oh, thank you so much. Yes, I have so much fun. So I work part-time at the Risk Center. I also work part-time at DesignSafe, and then the other part-time I play with a lot of neat and fun stuff. So today, what I wanted to do, instead of just go down a single path of talking to you about one project that I work on, I wanted to kind of add to your own vocabulary. You're mostly PhD students here, right? Graduate students and PhD students. So what I wanted to do was actually introduce concepts, things that you've heard of, and just tools that are out there that will help you with your research. For me, that's what I have fun doing is playing with these tools, figuring them out, and then moving on to learning a new one. And that's what I do with my time. That's what I don't get paid to do. I don't know. And so I'm excited. I really wanted to show you guys this. I'm going to cover a lot of ground. And this is your first sweep, maybe, on many words and concepts, which means where I'm going to plant seeds in your head. And I'm kind of known that when you leave meetings with me, you have more questions than when you came in. Okay, so that's my goal. I want you to write down, S3. The heck is that? And I'll tell you what it is, but you'll be like, oh my gosh, it's like the most awesome thing in the world. And so, because I talk about these things with people that do research and they don't really know about what's available out there to researchers, especially at UC where you have some discounts and some things. And so that's really what I wanted to do, is give you information for you more than talk about, what I've been working on. And there's two sides to this. One is what you can do with AWS. You all know what AWS is. It's a bookstore. Started as a bookstore. And it's Amazon Web Services. And it's just a tinker toy of fun out there. So I'll show you some of the fun things that you can do with it, as well as NSF DesignSafe, which is access. It's a research infrastructure it's a cyber infrastructure for researchers. And it's as awesome as AWS for a different purpose and different goals. And what I really like about it is that you've got people like me to support the research and using the tools and things like that. So it's really a major resource for students and researchers, whoever's working in the natural hazard realm. So very few people know about it, and I'm trying to get more people to even just know about it and go, oh my gosh, let me go see what kind of things I can play with over there. Okay. And so this new paradigm is really not just changing how we work, us sitting in our cubicle or in the computer room in a small world. Now we're connecting to bigger computers, faster computers, and bigger communities. And that's what DesignSafe purpose is to really build a community and exchange of information as much as data. Please ask me questions along the way. I've got a lot of slides. I don't have to cover them all. And I can talk about each one of these slides for hours themselves. So if I figure out how to go to the next slide. Yeah. Okay. And so that's kind of the focus that I want to do today. And I think I've already gotten that across in my title page, is that what we're doing now in natural hazard, and I put a lot of words in here because each one is important, is things have gotten more complex. Okay, we're working with big dynamic systems and a lot of data intensive. But you've got to keep in mind that complex does not mean complicated. Okay, and it's very important to understand it. If you understand something, then it's not complicated. It's just complex, and it's kind of cool if you figure out how to fine-tune the little machines, and it gives you a lot of power and flexibility. When somebody presents something and it just seems a little confusing, for me, it will seem overwhelming because it's just a lot. Then you want to go down and really understand the bits and pieces because it's really hard to get a big picture of everything as well. Okay, that's me at the Texas Supercomputer, and all this work through the AWS. I use AWS for certain things, and I use DesignSafe for other things. Okay, they serve different purposes, and you don't have to use one or the other. You can actually use them one for certain things and DesignSafe for other tasks, and really leverage the two, and that's why it's important to know. It's great because now most people are not just doing a simple simulation. You've got to do data processing. You're just expected, especially when you're doing risk analysis, it's everything, right? From beginning to end. It's the response and then how the response of the behavior of something, how it behaves over time, integrating over many different variables. And so you've got a lot of data and a lot of processing that you need to do that it's really hard to do it on your computer. Not only that, but not everybody works on, you can't do everything yourself, right? So somebody's going to do the analysis, somebody's going to look at cost functions, someone else does other components. And so what's great about these cyber infrastructures is now that you can collaborate, you can use data from somebody else and take it to the next step. So everybody can really collaborate and do different parts and looking at the entire risk integral at all levels. There's flexibility and power, a lot of power there and a lot of flexibility on what you can do. The more you know, the more little things you can do and play with. And so we're not just making it faster, but it's easy to scale it. And for me, I always talk about, and it's not with the computer science people's version of, I asked my husband to him, it means something different. So for me, scaling is like, there's vertical scaling where, okay, we've got a problem and now we've got bigger and bigger problem, right? More processors, more numbers, bigger data. But then also the scaling of being, okay, I've got this method that I'm applying in this theory. Well, how can I take what I have learned, my script, and do something different? You know, different types of applications and reusing your scripts, reusing your tools and building tools ahead of time to be able to have something that is flexible enough that you can apply to different applications so you're not always starting from scratch. Okay. The problem is you start with one and then I go to the next. I'm like, oh, I've learned so much. Now I go back to my original one and I try to improve that. And it actually kind of becomes pretty great because each time you're doing something, you're learning something new and some new tools. And so computer rooms are actually a lot of fun. It's really cool to be inside this big machines. A lot of repetition in my slides because I think it's important to emphasize this. We're really changing things from my days. I got my PhD at UC Berkeley in, I can't remember if it was 97 or 98, honestly. Okay, so I go back and forth. Things were different. We use MATLAB, and I remember being able to tell Matt and my friend going, Sylvia, come, look, this thing is called Mosaic, and you can read the newspaper in Italy. This is so awesome. We don't have to go and buy it. So this was very early days of just connectivity, and it was a passive connectivity. Now we actually have a much more active connectivity. So things have changed, and it's really, it's exciting how just more and more based on the basic concepts and you build on it. So you're never obsolete if you just keep up with what you're doing. It always just grows. And again, I'm a big fan, as I said a few times, of understanding. We're still trying to, so I'm a structural engineer. By training, I do a lot of ground motion work, but my PhD was in the lab testing beam column connections on a bridge. So it's really cool. And then I went into, as soon as I finished, I started working on OpenSeas, which is a finite element analysis program. And that kind of became my thing until I moved on to, I went to work at an engineering firm and they said, oh, here, I want you to become an expert in ground motions. And so I took another 90-degree turn and I learned about ground motions. And so it's kind of cool because my understanding in the lab of how reinforced concrete behavior behaves actually really helps me to understand what are the limitations and how real what we're doing is. Because there's people doing, you know, we're still trying to understand shear behavior in beams. I think we kind of have beams. Maybe columns are a little bit different because we've got axial forces. So we don't quite have it all together there. But then there's people doing these risk analyses over a whole region. And, you know, what happens if we have a magnitude, here in Southern California is a magnitude 8 on the San Andreas fault, right? And things like that. And, you know, what is the cost impact and the recovery? And those are actually very important decisions that they're decision-making. They're important tools because they're decision-making tools. So I don't need to know exactly what's going to happen, but I need to plan a response, right? So am I dealing with no damage? Am I dealing with significant damage? Where am I going to send my resources? Which bridges or hospitals do I expect to be the weakest? And sometimes it may be the weakest, but nobody goes there. So maybe a medium weak hospital that is in the heart of a highly populated area may be more significant than a different one. So it really brings in all these different variables into your evaluation and what we're doing. And so it's exciting that you can actually bring all this together. And there's some tools at DesignSafe for that. And what's neat is that what you're doing when you're testing the beam column connections in the lab, you're actually part of a bigger project that actually you're taking that data and that will get fed into what people use for developing fragility curves and many different things. And so this network connectivity of what we're doing makes what some people do seem small, but it's actually amplifies it because the data goes out there right away. I don't think I ever published my data from my dissertation. So it's sitting on this disk. And it was like this other type of disk. It wasn't even a floppy disk. It was like some new type that became obsolete. And so, yeah. So you've got more access. So it's not just power that you've got. It's not just faster CPUs. There's a whole lot of connectivity that is built, especially in the natural hazard world, especially in the earthquake engineering world. And now with the bigger impact of windstorms and climate change, there's a lot of more work done in wind, but a lot of the fundamentals and the resources are really shareable. So it's neat because now you can go to these HPC conferences and get to learn about fire damage and things like that. So our language just keeps growing, and there's always something new going on out there. So kind of in summary on this, to really kind of put it together, we've got large scale models, but they're dynamic, right? They're always changing. It's not something that we can easily predict. So there's also a time dependence. And so it's not just one model. Now it's, the storm and the storm movement across time and just all the different variables depending on which direction it's going in. Because we've got so much fast computational access as well as network, now we can almost do these analyses in real time, so we can predict which way the storm is coming. We can, focus on what resources are needed right away or immediately after an earthquake or immediately after an event. You don't have to wait for months, if not years, to process the data, evaluate it, and get something out of it. So I could just be collecting the data and I've done my part, and somebody else can actually take that data to the next step within minutes. In the old days, it was hard to access an HPC. Nowadays, thanks to Amazon, anybody can do it, and everybody can do it. And thanks to DesignSafe, it makes it that much more accessible because you also have support. You don't have to know everything you're doing. You don't have to know. So my recommendation is understand what the tool does. You don't have to know exactly how it does it. You don't have to program it, especially because the technology of software and hardware is always evolving. And so you're always using the latest computers and the system, quote unquote, always works. Or if you have problems, somebody else is there to help. What's really cool about AWS, and I'll hit it, is Lambda functions. Anybody heard of Lambda functions? Cool. So I love Lambda functions. It's called serverless computing. So I want you to just evaluate this Python. Here's in my Python script or anything. Java, it reads, I think even C#, somebody told me that you can do. So I've got a little calculation and you send it out, you send the information and it gives you, it returns the results. It's kind of cool because you can hide your code there, right? So you can integrate it into something else. You could do it kind of like a web services type of call, but it's something that you set up and it costs you nothing pretty much because you only pay. And that's what I like about AWS, you pay per use, but you can pay a lot. It adds up very quickly. Okay, so it's kind of neat. It's not just computer power, it's people power and community power and conferences and really going to these things and learning what other people are doing, because sometimes you can take the tools that people are using or developing, and there's something you can contribute as well as something that can contribute to what you're doing. So if we hit AWS, it's Tinker Toys. What's interesting about AWS is that a lot of big companies use it. So my husband works for Sony and they do everything using AWS. They're the big clients. We're nothing compared to that. So if I to use it, I pay like $2 a month to what I'm doing. I'm not doing much on it, but I have a lot of data stored. I have some things on there because I just use minimally. And so it's really cool that I don't have to be a multi-million-dollar company to access the same resources that they are using. And so it's really cool because, you know, when you've got money on the table, the technological improvements are just significant. And so you get to leverage that even as researchers. UCLA has a deep discount with AWS, so for research. So you can really, you know, play with the big guns, even on a small scale of what you're doing. They're all different kind of hits. I made in bigger font what's over here in the compute, and I'll show you my favorites on this. So compute is, you know, what kind of computers, the compute power, right? What's doing the processing and the number crunching. Yes?
I was wondering, you know, for a company like Sony, why can't they invest in their own stack or, you know, own AWS kind of a system rather than, you know, they being clients of AWS, where they know their data might be prone to kind of leaking or, you know,
Yeah, so that's a good question because my husband used to work at the Gap. AWS was their competition. And so then they built their own, they did everything in-house themselves just because they didn't want to mess with the data because you're in competition. I think at some point they may have switched over, I don't know, because nowadays it's much more reliable because you've got to scale things bigger. Not only that, so my computer, I just broke my computer. I break my computer every few years, just slows down. The fan goes out and this and that. And so now I have to buy a new computer. And I'll tell you about this because there's something that's called EC2 on here, okay? And it's something that we're using. So if you do it in-house, you've got to have the computers running 24 hours a day. But you don't need them those 24 hours a day, right? You've got, you need somebody to maintain them. So you got to pay full time and benefits that person. And so maybe if you are a data center, you could do that. But if you need data globally, you need to they're spending most of their time to test that, you know, always new implementation. So you can focus your resources in, especially with shortage of people, you focus resources on improving your own design of your games, of your things, and there's enough going on that you have to do yourself. And so you let somebody else handle that because it's like, oh, wait a minute. So this is, my husband worked at the Gap. It was like the web was losing money all year, but you have to be ready for that, you know, Black Friday, right? But so you're paying for software, 300, you're paying for a license. And so now we're going to SASE. Okay, software as a service. So now there's even platforms as a service, so that you only pay for what you use. And because we're all doing the same thing, it almost becomes a shared resource. And so it's great if somebody is actually doing all that, and that's their job, right? The supercomputer, they maintain it, and then you just use the resources that you need. Sometimes, some days it's a lot, and some days it's not so much. And so that's what's really cool. If you look at I have them here. So we've got compute, which is the nodes, the actual computation. And then you've got containers. Anybody heard of Docker? Okay, so not a Docker image, you set up what you want, and now you can run it somewhere, right? And so what you do with containers, so this is what AWS does as DesignSafe. So the two things are in TAP are very similar. You use a open source concept called Kubernetes, where you scale up. Oh, you need 100 instances to run this? Okay, poof, turn on 100, you rev it up. Okay, now we're done, turn it down and shut it off. And so if you're renting, it's almost like you're renting time versus owning. And owning, maybe it might be cost effective, but not always, because you can't scale it. Yeah.
So I think you're absolutely right in that in that conclusion about the cost. So in a previous slide, I worked for a big mining company, and you would imagine they would have like these servers because they have so much money. But the business of this mining company was to mine, right? Not to set up infrastructure, maintain it, and all that. So in the end, they use AWS for everything. Also, the data concerns. I would challenge anyone to try to build the most secure system than what Microsoft or AWS can come up with. It's very challenging to secure the data better than what they can provide. So.
Especially because it's important to certain companies who are willing to pay that much for that service. And so, yeah. And what's important about data, so if you have a program, what really slows you down is I/O, reading and writing. I don't care how fast your computer is, your chips and how many you've got going, but if you got to read that ground motion file, then you've got to save the data. And there's no point to doing something unless you write it. And now, so the speed of the chip where you write is important. Also, the proximity, okay? And so that's why if you go on AWS, you pick regions, right? Because you want the data to be, so if I don't care about the speed of the data, my data is sitting somewhere in the East Coast. But, you know, it's really, and it gives you that choice as to, you know, you want to pay for fast data? Do you want, do you want to pay for really fast access to it, or do you want to pay for it to be somewhere else? And so the security, when there's big money involved, like big companies, like you're saying, they'll invest. It's good for AWS to focus on providing good data security. Yes, that's a really big deal. And so it's and everybody wins, and we get to play in that minefield. It is a minefield. But there's a lot of advantages that we're getting from there. So and there's like everything. So there's compute, so you can choose. So I'll show you an example. For example, I think if you came, Professor Bezornia was talking about the NGA projects, and so I build the portals for accessing the data. So the NGA West 2, we did it somewhere else, and it's sitting on a peer server. For the NGA subduction, I was just learning about AWS. So we did it in an EC2. What's really cool about EC2 is you can start up a computer and you can shut it down. The one that we're using is started up and it's just always run, okay? If I buy one and it's always running, it costs me less sometimes. If it's got a lot of use, it's cheaper to buy it and get, I want this much memory, I want this kind of processors. You really get to to design the hardware that you want, and it's running the whole time. I want to pay for a license. You can do, I want a Windows machine. Costs a lot because you're paying for the license, or you want to do a Unix machine. And you literally throttle, turn it on or off on your computer. Be careful, make sure you turn it off if you want to turn it off. But it's very easy to do that. And so there's EC2 machines, which are running all the time, or you've got these Lambda functions that just, hey, I just want to do a really quick web services call, or a million of them. And then things get interesting because you pay for data transfer, you pay for time, you pay for every little bit of you do. And then there's storage, which is the S3. Anybody use S3 buckets? Good. So S3 bucket, and I say that, oh yeah, it's just in an S3 bucket. AWS has, and it's kind of cool because the sign is a bucket. So these are the ones I use. So you see, it's a bucket, okay? So these are my three favorites, and I've talked about, so the EC2 is elastic computing, okay? You can start up a machine, leave it running, or you can turn it on, do some computations on it, and really scale it to what you need to do. If you then do what I think I was talking about before about the packages, if you've got your own image of a machine that you want, you've got your Docker container, you can have your machine load up a certain Docker container. Okay, I want to run OpenSeas here, I want to run something else, and you can really do what you want with all these different things. Or if you want to just do something simple, you can just call up a Lambda function that you write up yourself, and it does exactly what you want. It takes in and it returns something. And then he says 3 buckets, which is just fast, reliable object storage, because it can store anything, okay? So now I'm really excited about learning about data lakes, where you can just throw so much data in there. We don't have to, no longer really have to go to build big databases in terms of big SQL databases, because that's expensive, you could just throw your files in there, and then AWS has some other way of, knowing what the data is and being able to take in and out of the S3 buckets. What's nice about the S3 buckets is that they're located near your EC2 machine or your Lambda function, and so it's a lot faster as well. And so you pay premium sometimes if you want things close. So when you're doing this on a supercomputer on DesignSafe, which really leverages TAC, which is the Texas Advanced Supercomputers, you choose, do you want to keep your data on Corral, which is just a big data server. But then if you're working on something, you move it into your work folder, which is a little bit closer. And then there's the Scratch files, which is even that much closer. But then maybe you might actually want to put the files in the temp of, the node that you're working on. And so you can really control a lot of that when you're working in DesignSafe on the supercomputer. You can go that deep into the control of what you're doing, or you can just stay out and just do the web applications that they've got. And so that's the beauty of what DesignSafe gives you, is these tools of kind of integrating everything else. The beauty of AWS is that you get to pick on what things are and what you do with it. So there's just a lot of different connections that you can make. So a simple example is you can run thousands of simulations on the EC2 and then store it in your S3 bucket and then do the post-processing. Maybe it's something simple with a Lambda function or a set of Lambda functions or whatever else you want, okay? Because then in the Lambda function, I could be in my browser and say, okay, I want to grab that data. And so you're really just doing a simple grab function, okay? And also, as the Lambda functions can be triggers to do other things, you can set up workflows. It's just awesome what you can do and go beyond that. So the summary of that is really, there's a lot of little things, and if you have a fun project or something that you're working on, just see how that could help with what you're doing. Now, on the academic side is something equivalent but different is DesignSafe. So DesignSafe is part of this national hazard. I don't remember. It's in the next slide. Okay, this is paid. This is kind of like, when you get a phone and you prepay everything. So it's not free. It's prepaid. We pay with our taxes, with our any sort of taxes that go to the federal government. It's funded by that. So yes, we are in danger of these things getting unplugged, but hopefully this is important enough. We'll see. And so, but they built the cyber infrastructure to bring together collaboration as much as hardware and resources. Okay, really building a community of just collaborative. It's really cool because you've got access to these supercomputer machines, but you can access them through a Jupyter Notebook, which is kind of cool. Now, Jupyter Notebook, most of us are used to using a Jupyter Notebook in Python and with a Python interpreter, but actually on DesignSafe, there's even a MATLAB interpreter in your Jupyter Notebook. There's a Julia if you're into faster computing and things like that. So it's all there for you to do even just on DesignSafe. So for the Jupyter Notebook, now I'm learning about Jupyter Books for the documentation. So it's kind of cool. So there's simulation applications like OpenSeas and AdCirc, which is for storm modeling. And then those can be integrated into your workflow and tools such as Jupyter Notebooks. And what's really cool, and I'll show you, is access to the data. You publish your data into, and you can actually get a DOI, therefore it counts as a publication for your OpenSeas analysis. If you do experimental testing, anything, if you package it and there's rigorous criteria, so you got to make it accessible to somebody else, now your data can be contributed to, or you can go and look for data from other projects and see what people have done. And then on top of that, there's the SimCenter tools, which are for uncertainty quantification, and I'll show you slides, and all the way to risk assessment, regional risk assessment. And they all leverage the tools that are in DesignSafe, and it's a sub-project, or it's a project that works within DesignSafe, but it's its own project. And there's a lot of really cool graphics that they've got. So at some point, there was a big challenge of let's study the natural hazards, but not just from the aspect of modeling, but also on the impact in society. Okay, because this is a government and we need to really think about, the impact of society for the decision makers, right? Where do we expand our resources because we don't have unlimited resources. And so it's a program all the way from, foundation all the way to impact society and decision makers. So it's very much what's the bottom line? How can we contribute to something? What I am doing is actually of value to something. There's sites everywhere. I work for DesignSafe, which is in Texas, but no, I do not have to live in Texas. And the Sim Center is up in Berkeley. And then there's sites, there's a really cool site. One of them is the Rapid up there. And they have, and I went with them, they have drones and they go and collect image data. And so I went with them to the fires up in, and so what they do is a researcher will say, hey, I'm trying to understand how the fire, why is it some houses were impacted and some were not, okay? And there's only so much we can see, and so they have a little area and the drone went up and down in both directions and it's all programmed. They're really cool drones. And so now they take this data, they publish this data on DesignSafe, and now I can go in with my image recognition data and maybe turn that into a database. And then I go in with and then they'll publish that data. And then somebody else goes in and do some fire modeling or something else. And so it's a really neat way of collaborating, connecting data, because that's a big one. I mean, we're all about data, but you need to have good data. And that's really the rigor that's brought in this, and communicating, connecting people. It's a small community. And so we can actually talk, oh, tell me what you did. Or I can tell you, oh, okay, with your drone, go and do this. And you submit proposals that you need the drones to go in and do some certain research. And then they have like this shaker machine, which is like, a truck that actually shakes the ground so that you can do some site response analyses and things like that. So there's a lot of facilities. It all kind of fits into what I was telling you. So that's DesignSafe is cyber infrastructure, which is where everybody comes and meets. Sim Center has some really cool specific tools that are run on tap through DesignSafe, and we collaborate with really the goal of impacting industry. As much as industry is not as, I'm trying to get industry to be more participatory in the research, but right now we can actually send, good, valuable data in the language that, simple plots, simple histogram, things that people can actually understand. Somebody's gonna have to stop me at some point, okay? So I've said it a few times already, so it's user-friendly, user collaboration. And it's really about managing data in not just using data, but creating data, processing data. That's all we're really doing. Even a finite element analysis is processing of certain data and certain models and things like that. Uploading, and what's really cool is that you don't have to download all that data. So I'm working with this project that the SCEC, Southern California, well, now it's statewide California Earthquake Center. So they do these numerical simulation of a earthquake on the San Andreas Fault and other scenarios, and this one actually does all the scenarios. And so they have so much data that I couldn't download it on my computer, but that's fine because now I use these other tools to actually use that data. So now these analyses are not just, ooh, look at all this data I generated. I'm going to show off what people can actually do with my data. You want to use these ground motions to look at your structure. You want to look at, the soil response. I'm interested. There's so many different things. We can study correlation of ground motions in different regions. So there's just so many things that you can do with this. And this is called, it's physics-based simulation. Some people call it simulated ground motions, which to me doesn't make sense. But, and therefore you have a really a diverse amount of data, uniformly distributed, because we don't have enough earthquakes, whatever this is. So the problem with it, a lot of it is not so validated, okay? So we have to look at it with a grain of salt. And so it's great that many different people do different kinds of simulations of, so there's the M9 project up in the Pacific Northwest. And now I can access both data sets, I can compare them. And so now, wait a minute, all of a sudden I've got that epistemic uncertainty, right? Which is that model and that model. So if I can compute a mean and a variation, so even just different physical models can actually be represented to give me, it's about somewhere around here. Okay, and then you can learn from each other and improve it and go beyond that. And so, as I said, access to large data sets and a lot of support. There are people who I work there half-time, and then that's my job, is to support people who want to run OpenSeas on DesignSafe, which is not trivial because you can do so much. So beyond just what you can do in a Jupyter notebook. Emphasis, I stole these from my boss, emphasis on data as well as simulation and data analytics, a lot of machine learning, because there's some big, powerful GPU machines, and there's some Jupyter notebooks on the GPUs. So it's important to understand what GPUs do. GPUs are just like an army. There's a lot of them, and they can just do certain things. So they're not the answer to everything. But they're great for screens like this, right? So understanding and being able to use one or the other is really the power of it. And so you could do studies, you could do some small tests, you're like, oh, okay, I'll do better with the GPUs that are so much cheaper, and I can use 1 billion nodes versus, I think like the cost is like 10-fold, if not 100-fold of that. So, and because there's so few nodes, I can't get to it until next week. So that 5 hours that I saved in analysis time, I had to wait in the queue to access those faster nodes. So it's valuable that you're not limited to, if we go back to what somebody had asked, well, why can't I just buy my system? Well, what are you going to buy, right? And so now it's like, oh, wait, I'm going to rent whatever I need. And sometimes I need GPUs and sometimes not. And then I can do a cost comparison and focus on what works for my project today. So that, to me, that's the value. It's like communism at its best. So, and it's great because on DesignSafe, you've got access to your own data. And then when you're ready to share it, you can share it with collaborators, you can share it with the community, and then when you're ready, you can then publish it. So it's great because you can learn a lot. You can test your data, improve it, and make sure it's usable before you publish it, and then nobody can use it because it's not usable. Okay, so it's really neat how there's just an evolution and growth in that. And it's all managed, and then you can go into there and go, oh, look, somebody did an analysis of a dam failure using hybrid FEM and NPM multi-particle motion. And so you look at that. So there's people who have OpenSeas models that they've published. You can publish, and that's what's really cool, is that now you've got some valuable things that you can actually publish and share. You've got these really cool scripts, but everybody takes my OpenSeas examples, removes my name on top, and puts their name on it. Well, now you can put something, you can publish it, and then hopefully they will at least reference what you're doing, and there's value that is shared and acknowledged in the community. So you can have a big impact as well with just all the quote unquote little things you've done. There's just a cool page where you can click on these different applications, so you don't have to work in the command line. You could if you want to, but it's all really just, that's our focus, is how can we make it usable and therefore used. Okay. This is the image I've been trying to create, that in DesignSafe and the community, it's not just the hardware at the bottom and the resources you have at DesignSafe, but all that really comes in that you're at a conference with other peers, people from this community, and you have an idea. And now you're in a place where you can communicate with other people. So you can collaborate all the way to, developing your idea. You can now develop some scripts and do some work that you can do, and you can do it directly there. So you can do it collaboratively. You can set up a lot of simulations. And then you can also do the simulations. And then you can do the post-processing. You can create some, Jupyter notebooks or, APIs to display your data, and then you publish it. And it's all there streamlined. So you're not moving data and losing things, and really, it's very good to track the work that you have done. And it kind of forms that circle of, that's where you can get some ideas and learn from others. SimCenter is some tools that are really cool on top of so DesignSafe provides you the Tinker toys, let's say, right? The support. Now, what SimCenter has done is develop these really cool modular tools, so you've got, the damage analysis, the structural analysis with OpenSeas, but now you can bring in doing, hazard, the ground motion analyses, right? What are going to be the ground motions that I need to input into my structural model? And so that is site dependent. So there's a module for getting the, depending if you're doing a scenario, if you're doing, hazard or risk calculation, So there's a module for the ground motions, there's modules for structure analysis, and then you can put in damage functions, or that can actually be included in your open seas analyses. There's loss function modules, so maybe you could be doing a very simple analysis and bring in these metrics. And then you can even go to recovery. A lot of people is talking about functional recovery these days, right? So that's another module that you put on top of that. What's really cool is on top of that, now you can put in uncertainty quantification, okay, which is very, very important, especially when you're involved in risk, right? Because that's where the big metrics come in. And so there's modules that you could do all these different types of uncertainty quantifications that you can learn about. You can use these to also calibrate your model against data, just lots of little toys and tools that fit together into the application that you're trying to do. They've got a whole, different levels and different pre-made modules versus not, access to QGIS. There's this thing called Brails that is literally web scraping. So they go into the Google Maps and they get information from the 3D buildings in Google Maps. Then you can go in and scrape, and you can do some image processing. Then you can go and scrape the city data to get permitting information and maybe information about the age of the buildings. You can get information about infrastructure. And then, what this tool does, it scrapes the internet and puts it in different layers. And then there's called something R2D, which is like risk and resilience, where now you can integrate all this together into something. You could do these really cool maps. And you can really focus on every little bit, and you don't have to worry about programming something, the workflow, again, of really being able to plug and play as we do these days. So all those tools are there. And then a lot of training, a lot of training. There's this, the Near East Summer Institute, I think right now I don't know if the applications are done. There's a lot of undergraduate programs and things. So there's a lot of educational programs, either through DesignSafe as well as Sim Center, to look at what they've got. They've got online tools, courses, they're on my case about, oh, you did that seminar at UCLA the other day, the training that we did at some symposium. I want, you need to put this into examples and things that people can actually work through themselves. So I know the Sim Center's got a lot of these, and we're working a lot of these also on DesignSafe to help you to access things better. And so really, I really want you to walk away with this picture that it's a whole big cyber human infrastructure. Okay, I think missed out in the name, but I think it's the expertise. People have different expertise in different things, and it really expands your language, and you can become a polyglot and these kinds of things. So it's really, it's exciting what's there, and I don't think enough people know about it. Quick comparison, but I've kind of talked about it. They both help you to automate tedious work. Yes?
I have a question about DesignSafe. And this one is good, I think. Say in the system you have, somebody has done some great work, they have their input data published, they have their process, their application published as actual code that you can run, and they have their output data published, right? So conceptually, you could step by step take their input data and recreate their output data, right?
Yeah, it's important that they provide enough to be able to create it, yes.
Right, so that process exists, and perhaps there's a lot of data, or it's too computationally expensive to actually go through and do that process to replicate. But you have a new data set and you want to apply it to this application. A common issue, I think, would come up would be if you try to take that application and your data, you have to set up your environment somehow, such that it's correct, such that it's replicating what the actual thing is doing. But at the same time, you might not be able to actually have the compute to run their machine on their data to verify that your environment has been set up correctly.
Yeah.
Are there solutions for that in this sort of context?
If you can communicate with whoever created the data, everything is open source. So oftentimes you're going to have to modify what you're doing with the data.
Okay.
And so I don't think it's ever a perfect situation. Now, you kind of, there's enough rigor in the publication and the requesting, make sure that you provide all the input and everything. Rerunning what somebody else has done, you assume there's enough peer review in what's been published and validation and verification that you've got to take it and go forward with it, just as if anybody had published an algorithm somewhere else. If it's open source.
I'm sorry,
It's tricky.
I don't mean to verify that the data they published at the output is correct in some
Right.
sense. Like you just sort of assume that. I'm just saying that when you take this application, put it on your machine or whatever your machine is,
Yeah,
you need to make sure it's working correctly or you're using it correctly.
right.
And I imagine the only way to do that, outside of just assuming it, you've set it up correctly, is by running it on their data, right?
Yeah, and you can run it on their data where they are, or you kind of got to figure out if you set it up correctly, you got to take a leap of faith and see what you're doing with it.
Yeah.
So that's a complicated question.
Yeah.
Because you'd have to look at the specifics of what you're trying to do and understand it. Now, what's really cool that people are doing, so somebody at Caltech, so we're uploading this data set of these simulated ground motions, and it takes so much computational power. So somebody is taking that output and using it to build some machine learning algorithms that then can produce similar results, but then you can make tiny little changes of maybe a different magnitude, but it's studying based on the studies or the data, it kind of comes up with an equivalent model of the wave propagation, never perfect, but now you've got a large enough data set that maybe we can create a different variation. Maybe it's not a magnitude 7.5, it could be a magnitude 5, because sometimes smaller magnitudes that have bigger recurrence behave differently as well. And so it kind of really depends on what your goal is with what you're doing, and you're never going to be able to repeat exactly, even if you were the same person and you run it today and then in 3 weeks, who knows what you'll get out of it if there's any imperfections in what you're doing. So, and that's the human aspect of it that makes it complicated.
It's just cool that you have this system that has all of that together, that you're almost there. Like,
You're
you could
almost there,
do that.
and that's the point is, okay, well, what can I do with that data? Or what can I learn from your algorithm? It's a great place to start, and then I'll modify it to my data set. More than hardware, it's more about your different applications. So, yeah.
So, as you mentioned, DesignSafe appears to be like a combination of three key things. One is like the hardware that is in Texas. The other one is all the software packages, application, examples that people have collaborated, and also people itself, right?
Yeah.
Okay. So, other than just cost, this being free and AWS or Azure or whatever cloud provider being very costly, what is the motivation to have the hardware layer on this project? Because it could also work only with the software and the people collaborating on AWS, for example.
Yeah, so that can work, but you have much more, you can work with the latest technology in the supercomputer. Sometimes the supercomputer at Texas may have faster machines than what's on AWS because it's a different scale. It's just one farm versus many farms. And it's not, I think a lot of it is just physicality, that you don't have to move such large data to AWS. And the cost of moving data in and out of AWS is what you pay, and storing it. So the cost gets really, it gets really high even at a discounted rate if you scale it up to this level of scale.
So this scale, there are like cost benefits of
There's, yeah.
owning your own infrastructure.
Yes, for the super, well, especially because you don't own, you see, we're not owning our own infrastructure, we're leveraging a different system that, so TAC, we're like a minor little user of that supercomputer. See, now we're sharing resources actually, because there's huge projects in the weather and NOAA, and there's much, we're a tiny little player, but we're different because in what we do, for me as a structural engineer, I have more metadata than data sometimes, right? I've got my model and I've got all these displacements, but each beam has its own reinforcement at one end, at the other end. So I have more information about the data than the data, right? If you're doing weather patterns, it's just lat long and everything moves, and then you've got these waves. So it's big data. Ours is like big metadata is really what we're working with. And so when somebody brought up GPUs are great, or GPUs are great, but they're not great if you're doing a nonlinear response history analysis where you need to iterate on something, where you need to think about it and try different and things like that. So you can, ship off small. And so somebody's like, oh yeah, it'd be great if we, I'm like, no, I think you just need to do a better refinement of your mesh and a little bit more intelligent models so that it doesn't take that long. But what we do in structural engineering is and I think just maybe in even mechanical systems, I assume it's similar, it's different because we have more metadata and data. And so then now you need a different type of computer system and things. So, but yeah, see, we're leveraging a different, and they got a $5 billion project because now we're joining the arms race of, who's got the fastest supercomputers in the world. China supposedly does, but they don't publish it. And so now you're talking about the global race of who's got the fastest supercomputer. And now we're leveraging that. We're like, oh, cool. Yeah, and we get to use it. So there's that game as well. And it is a shared resources. And that's what was so smart about this is that DesignSafe didn't build its own infrastructure. It's collaborating with something that was already existing. So, yeah. But that's a really good question. So, yeah. And then comparison of the two, I think we've talked about this enough. It's cost. Oh, and it costs right now. There's no limitations. It doesn't cost you anything to save data, to store data on TAC. At some point, remember a short while ago, got an email from Google saying, you can't keep more than 5 gigabytes or 5 something. I'm like, I've got 2 terabytes on 3 different accounts. And I lost a lot of data in that. So at some point, maybe that could happen, but who knows? But data is a big, big issue. And so the proximity of the data, not having to transfer the data is really a big value. Yeah, it would take you just that much longer to get it to AWS that you might as well just do it locally. And so that's why you kind of bring it. Proximity is really important. I wanted to show you a couple of applications, but I think I've kind of hit them already. So I'm an application specialist at DesignSafe. But I just joined a year ago, so I'm working through really leveraging what all the awesome stuff you can really do with, the Pi launcher and the way that they can do the Slurm jobs on the HPC. But I've even used it before. I've developed an elastic response spectra, which is like 1 billion tiny little OpenSeas analysis. Tiny, but many, many, many of them. And it took me forever to figure out how to manage because you got to record them, then I got to compute the raw D50, which means you bring them all in, you got to get something out, and just a lot of headache in managing that. So my goal is to make that a little bit better and more streamlined. But it's really neat that you can do all that locally and then publish the data. I've been doing a lot of stuff on AWS on different levels. I've done a lot of stuff with UCLA projects. And then I've also done some stuff on my own I have my own app out there and just excuses to really learn something new. So I kind of wanted to show you some fun things. So this is my big image of what you can do and what I've done on DesignSafe. You can start with a tiny little simple single degree of freedom analysis that you could do on your laptop. But you got to remember, as you scale up in number of ground motions, in the size of your model and all that, it's not just more computer power, but it's also data again, okay? And so that's something important. It's not just being able to run something, it's what to do and get some results out of it. And so that's really what's neat, that you can do all this within one location. You don't have to, I have files in many different places. And then again, you can collaborate and leverage other people's work. We have the the NHR3 web portal where I have a couple of tools there. Well, I guess I have an outline on it, but I'll skip through. And so this is that EC2 machine that I told you. You set it up as a system, it runs, it's on Ruby on Rails. If I were to do this again today, I would put this into a Lambda function, okay? We've got this machine, it's running, which is fine, it doesn't cost us much, but I need to have someone else to configure the system for me. I needed someone else to, if I have security issues, because the security login is something that we wrote 10 years ago. Now, AWS does it automatically, you know, there's a little app for that, quote unquote. We don't have people running, this is just to search and download ground motions. So it doesn't need to be running 24 hours a day. So again, a Lambda function, right now we've got 1,000 people that want to download ground motions. And then, you know, for the next 3 days, only 3 people do. And so if it's on a Lambda function, it's, you know, as if you pay, quote unquote, pay per use. But it's not just pay, is if I want to make upgrades and improvements, I'm not stuck in an old operating system. I didn't have to decide what operating system I wanted and, you know, and plan on that. And so this is awesome. Now, what's cool about this is that first I did the NGA subduction, then I added another portal to it, another tool to it, and another tool for inundation modeling and other things, just because I had everything configured already. And so it was great because I just put in another web interface because we weren't really using up the resources. And so if you've got something that needs to run constantly, this is a great way to do it. It's neat because then you write the code in just JavaScript and HTML, and the back end, you write it in Ruby, which is this weird language. But it doesn't matter. It's just how you do vectors and if statements. I could do a lot better now with Plotly, what you could do with Plotly these days. Oh my gosh. But I enjoy a lot lately I've been doing a lot of maps. So this is, someone else ran a PSHA at 19,000 points across California. And so I have all this data, you know, what is the PGA at each one, what is just different metrics, and I put them all into maps that you could do using Leaflet, which is free instead of Google Maps. And there's just, and then you can make these, so I'm really into creating interactive maps these days, and free. And then you put them, these are on the EC2, but then if you just put them, so what's really cool about the S3 bucket is you can put an HTML page on there with JavaScript and everything, and it renders it. So you can have your own web page and it costs you nothing, okay? Then you put a Lambda function, that's what I did. I have a ground motion selection tool that then, you know, I do all my little JavaScript and everything, and then goes to Lambda function to do my little code to do some processing, and then it returns the values. And it costs me so little because it's on, because if you try to put HTML in Google Drive or anything else, it can't render it. But S3 buckets can. So if you want to set up yourself a nice website, and then you could do the Route 77 or 73, where you can actually set up your own URL for it as well, and domain name and everything else with it, which is something else I'll show you that I did and played with it. So it's cool because you can do, you know, maps and things like that on these. What's nice is just the rendering and the data takes time, but once you figure out, it's kind of neat what you can do for displaying the data. And then you put it into into your S3 bucket and you're set. You see here, I wrote something, you click on that and opens up these windows. You've got JavaScript, that you've got pull down menus and different things. I'm highly involved in the building code these days. We're doing some big changes on how ground motion and design ground motions are defined these days. And so I had to do a lot of maps on the effect of these changes that we're doing. And so people are like, oh, how does this impact, you know, the new Madrid? How does this impact where I am? And so I did these interactive maps that they just sit in the S3 bucket. And it's a lot of fun. And then you put layer on top JavaScript, and a lot of neat things with Leaflet. So if you're doing maps, well, you could do stuff with QGIS, which means that you got to get something up and running. You got to learn GIS. You got to learn all this. Do it in Leaflet, it's free. Google Maps is great, but you got to pay for an API. Leaflet is free, and there's so many things out there for it. And a really interesting, and this is the ground motion tool that I have, that I've even set up, a thing that you pay. This is my own things that I've done. And so this is what uses the Lambda functions. And then I put in Plotly's. This was a fun game that I have ADHD, so I go down a certain path. I did this widget spinner because I wanted to learn how to do the things. And so you actually go in, I need to improve the UI of it, but this thing spins, you can do different shapes, and I was just kind of playing with it and things. So I've even built my own app out there with JavaScript and HTML. Now, an important thing, I have a question for you. How many of you guys use Jupyter notebooks where you create plots and so plot of a lot of data or maps using that nice package in Python? Anyway, how many of you guys use Jupyter notebooks to create large data plots and things, right? So nice thing about Jupyter notebooks is you can display a lot of data and processing. But then if I have to share with somebody else, there's ways to do it. I use my binder to put it in Jupyter notebook. But then if you want to share a plot with somebody, like a Plotly plot, which are really nice and highly interactive, if you generate it in Python and you do a loop through the data, and then you save it to HTML, you end up with a really, really large file because you're looping in Plotly, and every point you're looping through and writing, for this click, do this. For this click, do exactly the same thing, but with this value. Well, throw that out the window and do this directly in JavaScript. And so that's what I've been doing, and it saves a lot of space and time. You can do exactly the same. If you're not doing significant calculations, you can do it in JavaScript. Okay, so that's my little spiel on what a great way of making your files that much smaller and efficient. And so that's why I kind of switched over. I do a lot of work directly in JavaScript, and that's what I like with S3, because then I just load it up there and I can send it to my collaborators and say, oh yeah, these are the plots that I've done. Here's the maps that I can give to the engineers to look at. So even for tiny little things, you can really share data. And AWS and putting it in open bucket, you can put public buckets, you can control all the access. Or you can do things directly in DesignSafe for collaboration with different purpose. So different things that you can do are in the two different places. So I think that go out there, Google DesignSafe, Google AWS, YouTube has there's some really good YouTube videos on doing stuff on AWS, and there's some really bad ones. So just kind of, I kind of jump around from different ones, and each one shows me certain things and things. And then just do it. Find a little project or something fun to do when you do it, and you learn a lot from it, from something that maybe you've done already before. And thank you. I was hoping, but of course I never leave time for discussion, so I'm happy you guys ask questions. I'm happy to stay if anybody has some more general questions, but we're hit for 1 hour. Yes.
I kind of want to go back to one of the comments that you made of trying to get more companies involved. And I was curious if you were referring to, like, what kind of companies were you referring to? Because what I immediately think with these things is, like, if insurance companies get involved and this kind of like more regional risk assessments, and
yeah. So insurance companies, I think, are sponsoring a lot of this work, of this research, because it's research, which then they can use these different algorithms in what they're doing.
Right.
So a lot of the work that we do is sponsored by stakeholders.
Yeah.
All right, a lot of work that I do is sponsored by Caltrans, right? Ezra and I are on a project sponsored by Caltrans, because they want to be at the very ahead of what's coming up and what's coming in. So a lot of it is sponsorship in that, because it gives you, and they're happy to share this, you make a better world. Insurance companies are tricky because it's very much of a one-way communication. If you're good at collaborating with them, Professor Bozorkin is very good about collaborating, and because then what's important about research is that it has to have value in what you're doing. And so if you're working with, the stakeholders, then you're actually doing valuable research. And so you communicate with them and say, okay, this is what we're doing. This is where maybe you could push things forward. On the side of, so they sponsor a lot of this directly or indirectly. You can actually use DesignSafe if you're in industry. It's a different price structure. You pay for it. But right now, you don't pay for data storage. So you could pay for CPU time, but you don't pay for data storage. And when I was talking to a company about, because you can run OpenSeas on AWS, they're like, oh yeah, it's great to do things on AWS, but it costs a lot of money to download the data and to transfer the data. And so that could be a means. And so that's when they build their own cluster. But I don't know how sustainable that is, because maybe if you process the data right there, you don't have to download so much. So if you now make a workflow, and so that was the two places where I see stakeholders coming in.
And so especially now where obviously a lot of other disciplines are looking towards like more resilience, like risk and resilience research. I'm wondering, even though this is like natural hazards, if you've had, or if like people that are looking from the transportation aspect. Because funnily enough, I work more on transportation, right? So, and like the big questions of like natural hazards and how do you incorporate that into mobility and transportation models and things like that.
Yeah, so there's a lot of that comes in with the SimCenter tools of now you've got these flows and transportation and traffic. And so you do simulations of, okay, this bridge comes down, how do we reroute and prioritize? So that's when you run the scenarios. Okay. And that's when you run all those scenarios so that then you can put them into a probabilistic framework, and you can do a cost analysis as well, and you can really optimize which bridge you need to retrofit, because you can't, and well, you could retrofit them all, but now we've got the time component. So which one needs to be done yesterday and which one needed to be done 4 days ago, and prioritizing your action. So that there's a lot of that in the transportation and the work in these regional assessment. The other thing that's important for transportation is studies in my world of ground motion and earthquake, but I think sometimes it could be similar with storms and floods and hurricanes and things like that, is correlation. Right? So we're talking about, a magnitude 8 and we're all designed for this. Well, that magnitude 8 over there is not going to hit every place the same way. And so, but now if the epicenter, hypocenter is over there, it's going to come in this way. If it's a hypocenter is over there, it's going to come in a different way and have a different impact. So the same magnitude 8, it really depends on where it started and where it's going through and where is it going to. And these you need to run large simulations to really do it on a statistical level. And so that's where that also comes into looking at, what's the correlation, how likely. So we do the same in designs, like 10% probability of collapse given the MCE. Not quite sure what that really means in general. So does it mean that my building has a 10%? It's like, it's going to rain. There's a 50% probability of rain today. What does that really mean, right? And so same with this is like, but it doesn't mean that the whole city, so if 10% of the city collapses during an earthquake, that's really, really bad, because it's not a 10% probability, because most of the city did not feel the largest shaking, okay? And so we really need to look at geographic distribution of response, and you need to do that from a probabilistic approach, because we don't know exactly which event is going to happen. And so that's where you need to scale up your computations and approach this decision making, right? And so that's where it doesn't matter which column is going to collapse or how it's going to. I'm not trying to predict the behavior of a building. I am just trying to decide, is that building going to go down more likely than the other, and things like that. And so it's exciting to think that it's important how good your models are, but it really kind of isn't either. So, but now the big money is in forensics. Now you really need to know exactly what happened, and that's where the big money is. And so then that's a different approach as well. So yeah, you can skin the cat in many ways. I'd love to hear, I'm happy to stay for more questions if people have questions and things. So I was hoping to make it into a discussion more, but.
I don't know if anyone online has any questions?
Anyone left on that?
Yeah, there are.
There are questions?
No, there are no questions online. Or not yet, not that I've seen. Yeah, we have few participants yet, but.
Okay.
Okay.
Anyone else here? But just,
Maybe I had a question about, me being able to download or, me being able to upload my data onto the servers. Let's say I do some kind of simulation, I'm able to download it. Is there some kind of a latency which, would be beneficial for me, if I'm doing real-time simulation, or if I'm trying to get real-time, information out of the simulation from you? So is it like I have to let my simulation run for the entirety of the simulation and then kind of download the data, or can I do it in real time with no latency?
so I'm not quite sure I fully understand, but so if you're doing simulations in real time and you want to visualize the data, you need to access the data right away, right? So that's when it's best to do it locally because the latency in downloading is tricky. And so it really depends on how you are doing it now. So if you need to get some data and post-process it right away, okay? So it's funny, I have a whole other set on concurrent. It really depends on how you manage your distributed analyses, right? Or your model. Are you doing a domain decomposition or are you doing just lots of scenario, tiny little analyses that are independent? It depends on how you run your parallel computation. So if you use in Python, the fundamental is there's a package. Anyways, so the one on top of it is called concurrent futures. If you go on my website and you go to the blog, I've posted a lot of these things that I've searched, I just put them into, that I get from my tech shaman, which is ChatGPT. I learned a lot, oh my gosh. And so you can run your analysis in different ways. So you can do it through a map versus a submit, where you can run something, and if you've got another process somewhere else that needs that data, you can just have another process that is working on the same node and grabs whatever comes out and does it. And so if you output your data, or you could do it in memory, depends. Again, now it's really about is it better to do things in memory, or is it better to do things in saving the files and things? It really depends. You got to test it out. So you can do a lot of this in memory directly. That you use this multi-processor in concurrent futures, and you do the submit, and as soon as the output gets returned, you can post-process it and do the next step with that data. Now, that is one way of running, but if you're doing an optimization, so that would be like in a Monte Carlo type simulation. If you're doing an optimization where the next run depends on the results previously, then you use the map commands. It's going to run the series of tasks, and then when they're all done, it's going to go on to the next step. And so that really comes in on how you manage your analyses.
I was thinking like more in terms of this big, I would say, finance companies, where they are like kind of getting live trails of data coming through, let's say NASDAQ or S&P 500.
Oh, okay.
So like I'm trying to understand, how do they manage real-time data or high frequency low latency data coming through, and what kind of systems they might have. Like, are they still based on AWS, or they might have something which is more local?
I honestly don't know, but if I were to get data from NOAA, would be one location. A lot of places, a lot of things have just it's a simple web services call, right? So, but I wonder if I do it often enough, there may be a back door that they have a certain API that you pay into, right? So I wouldn't be surprised if the NASDAQ has an API that you pay. And so that gives you much faster, more real-time data that you can get. And then, you kind of figure out, okay, I'm going to do it close enough. And the speed of things for that kind of data it's enough, it's fine to have some latency, it doesn't matter.
Right.
So, yeah, I mean, that's like seconds, and seconds is an eternity in terms of computer time. So I don't think latency is really an issue on that kind of decisions. So, yeah, it's interesting to see where, and learning about APIs is a cool thing too. Thank you, guys.
Thank you so much.
This was a-
That's here for everyone,
yes.
except the people on Zoom.
Go get a cookie, that's what we used to do, go get yourselves a lunch. Thank you, everyone, thanks for all the
Thank you.
valuable questions, this was very helpful, so.